Okay. So we've been continuing creating our world. Today we're going to look at a couple of new things, I think, for the homework today, and I'm not going to recreate it in here because I'm going to do it in a, let's say, better way. You were to kind of build out that whole map, practice creating instances of the objects and stuff like that. Now we're going to go ahead and say, you know what? It sort of makes sense that if, let's see, where's my... class is this 250. It sort of makes sense if we're going to have a map like this, and we might want to kind of design our maps outside of our code rather than have 50 lines of code in there, that maybe we put this stuff inside of a file and we read it in. So we're going to look at how to do that in Java, but more importantly, what we're going to do is we're going to practice reading the documentation. The documentation is going to tell us how to create these objects and stuff like that for doing it. So we're going to start off with just a sample file with some stuff in it. So I'm going to create a new file here. And we're just going to call this, I don't know, we'll call it map.txt. So it's just going to be a file that has our map in it. And we're going to just put a couple of lines in here of just some text, just as a kind of a starting point for our file, because we're going to practice reading some stuff in, and then we'll think about, well, what do we want this file to actually have in it to read in our rooms and then our exits. All right, so I have a file called map.txt. Now, before we actually do the file IO part of this, I'm going to just get rid of, I'll just comment this out for right now. So just like in C++, that's a multi-line comment, /*, / everything in between is a comment. What if we want to read stuff in from the user? Because we're going to be pretty soon looking at doing that, where the user is going to say, hey, what direction do I want to go? I want to go to the north. I want to go to the north, and so on and so forth. How do we do that? And we're going to introduce this idea of something called streams with Java. So inside of Java, and it lives in the Util class. And actually, let me show you Java. So here's the scanner class in here, and it lives inside of java.util. Let's see, can I? All right, so I wanted to just show you ahead of time kind of this package called java.util. So because we're already starting to use stuff from there, we've used array list from java.util. So this library must have a bunch of utilities in it that might be commonly used in solving problems. So just as a quick glance at this, there's a bunch of stuff in here. A lot of collection things, a lot of things we're going to write by hand next semester in CSC250. But we have our array list. We have a bunch of different things. We have a base 64 encoder, decoder. It's something you might talk about in the cybersecurity classes. We have calendar stuff. We have a dictionary for name value pairs. Hash map, it's another collection type. List stuff, collection type linked list. We're going to be writing linked lists and linear linked data structures, the first part of 300. Random number generator. Here's the scanner we're going to be working with today for doing IO stuff. Stack. So those are things that are in the util class. But we're going to go into our scanner. So scanner, this says a simple text scanner which can parse primitive types and strings using regular expressions, whatever. So let's go down and see, how do we build a scanner? And then we'll see what kind of abilities it has. So there's all sorts of ways of building a scanner. The one we're going to look at first is this guy right here, a scanner that takes in a input stream. What thing am I reading from? What am I scanning data from? All right. So we're going to say initially, if I'm reading something from the stuff in from the user, I want to read in from the keyboard. And what's the keyboard called? Well, we've seen it before. It's called system dot. Well, we've seen system dot out. That writes out to the screen, right? So in our system class, we had our system dot out, which was a print stream that wrote to, it's the standard output stream, which is the monitor. But then we also have something called system.in. It's a static field of type input stream. And that's the keyboard. Standard input stream is the keyboard. So let's go back to. So our constructor here, the one we're going to use, requires an input stream. So I want to create a scanner. And this is inside of java.util. So I'm going to import java.util.scanner. So I have access to that class. So I'm going to say scanner input is equal to new scanner. And we saw there's a bunch of versions of the constructor, a bunch of ways of constructing scanners. What's it called when you have multiple constructors or multiple methods with the same name but a different number and or type of parameters? That's if we want to. We overloaded the method when we looked at toString. I'm asking what's it called when we have a bunch of methods with the same name but a different number in or type of parameter. We looked at that with the println method inside a system. What do we call that? What was that crazy name for that? Go ahead. Polymorphism. All right, so more of trivia knowledge, but polymorphism is when you have more than one method or constructor with the same name. For example, a whole bunch of constructors. They all have the same name because constructors always match the name of the class. But these guys take in a different number and or type of parameters. Okay, and we're picking the one right here called that just takes in an input stream because we want to read something in from the keyboard. So it requires me to give it an input stream. The input stream I'm going to give it is a system.in. Remember, in was a static input stream inside of the system class. So since it was a static field, we call it with the name of the class in which it was defined. System.in. Just like when we're writing something out to the screen, we say system.out because out is a static print. Oh, was it print stream? I think it was a print stream, but whatever it is, print stream or print writer, one of the two. That guy was a static class inside of systems. We call it using the name of the class in which it was defined, system.out. Okay, so we're going to build this scanner around the stream associated with our keyboard. And then we're going to, here we'll prompt the user. And then we're going to start off by saying string num is equal to input dot. Now we need to go and look at the documentation and see what abilities does the scanner class provide to us for maybe reading stuff in. So we'll go into scanner. Let's go and look at the methods this guy has. So there's something called next line. So next line advances the scanner past the current line and returns the input that was skipped. So whatever you typed in on the line, it'll move all the way past that and give you the chunk that it read in as a string. Next line takes no parameters. It comes in as a string. We don't see static here, so that means it's a instance method. So how would we call the next line method? What do we need to call the next line method? Go ahead. An instance of the scanner class. And we have an instance of the scanner class right here. So we'll say input dot next line. And then we'll prove that we read stuff in. We'll just echo it back to the screen. Once we enter a number, I'll put in a 55, press enter. It read it in, spit it back out to the screen. Okay, but now I verbally, well, I guess textually said, give me a number, but I read it in as a string. That guy came in as a string. So if I say I want to add 7 to that number and I put in 55, my output's going to be 557. It's not going to do math with that guy. So there's my 55 and I get 557. So since I was working with a string on one of the sides, it treated the plus sign as the concatenation operator, built a string out of it. Okay. Now I probably want to work with a number. Now the scanner class does have the ability to read in specific types, but rather than use the scanner class to do that, I'm going to read it in as a string. And then I'm going to manipulate that string. I mentioned the first week of class that Java is a string-based language. So if you can get something in the format of a string in Java, you can do a lot of stuff with it. Strings are very malleable in Java. So right off the bat here, I have a string called num. Now what I can do is, maybe I'll call this guy int num as int, something like that. Now, string or num is a string, and I want it to become an integer. Now we originally had looked at the character class, you remember, week 2, whatever it was. And we saw that there exists classes in Java for working with all of the primitive types. Why is that true? Because primitive types can only hold a value, right? So we might want to do things to primitive types. So we're going to say, hey, let's go take a peek at a class called integer and just see if there's something in there that might be beneficial for us for turning this string into a number. Okay, seems like a reasonable place to look. All right, so part of this is, it's handy to kind of know the core places you might look in the documentation, but sometimes you're going to need a Google search that says, hey, go and look at class X, and then you look at it. But our important skill in here is that we know how to read the documentation for any class. We now possess those skills. But I'm going to go ahead and we're going to check out the integer class. All right, we know that there's a class for every one of our primitive types. So here's the integer class. And we kind of scroll down. We see that a lot of these guys are static. And we see here that we have a method called Parse Int that takes a string as a parameter and it returns that string as a signed decimal integer. Converts the string into a number. That's what it does. Okay. Notice there's actually a second version of Parse Int here where you can give it the string, but tell it what base the string is currently in. And I'll show you that here in a second, but let's just look at the first one. So parse int is a static method. So we call it using the name of the class in which that method was defined. Parse int here was defined inside of the class called integer. So I'm going to say integer dot parse int, and I'll pass it my string. So num holds the string that I typed in. I'm then going to pass that string into this, think of it like a machine, right? I toss a string in, it spits out a number. That's what integer.parseInt does. I'll catch that number in this variable called num as int, that is of type integer. And now we'll use num as int, which is the int version of that string, along with the addition. And now you'll see it'll actually do math. So there's my 55, and we should get a 62. Make sense? Like I showed here, and this is only sometimes going to be beneficial, but we did write it last semester. In my classes, I do a lot of those conversion things, converting between bases. Sometimes if you want to work with those, parse int, I can pass it a string in the format of one of my bases. So if I want to pass it binary and tell it it's in base 2, it'll spit out the decimal version of that for me. So I can just say, enter a, we'll prompt them better, enter a binary number. And I'm going to read that in as a string. I'll pass that string along with what base it's in. We'll run this. So I'll tap out some zeros and ones. And that is the number, well, it's 855 because I'm still adding 7 to it. Take the +7 off. So it converts a binary representation of a value into its decimal equivalent. Similarly, I can say base 8 if I want to do base 8. And I need to make sure that I give it values that are legal base 8 numbers, 0 through 7. But I'll probably get a number format exception if I give it values that aren't legal. There's my number format exception. Go ahead. So now yep. So if we go back to the system class, I'm sorry, the scanner class, and we look at next line, we see next line gives us a string. So if I'm going to use the next line function, my ability to read in a string with a scanner, if I'm going to use that guy, I'm going to get my answer as a string. Even if I want it as a number, I'm going to get it as a string. Yep. So I'll catch it as a string, and then I'll do my manipulation to it. Now, you may have noticed here, there is a next int method that will directly, effectively do what we're doing right now. Yeah, it'll do it for you. But what it also will happen is that will read in, you could have multiple integers on a line and only read in the very next one. It won't read in the entire text that was entered in. I can enter in 55, 72, 58. And if I say next int, it'll just read in the 55. It won't get that next value. I would say that I typically will always work with things as strings and then manipulate them as necessary. I think that's kind of maybe the go-to move. But if you know you're working with integers, next int is fine. Yeah. Well, it's not necessarily better. Yeah, I mean, this is just the way it's done in Java, but scanner will work on broader types than CN. Yeah, and we're going to see that here in a second. We're going to use it. We're going to use the same thing for doing file IO. Right, because effectively what we're doing right now is we are reading in from an input stream, and that input stream happens to be the keyboard. What if I give my scanner a different input stream? What if I give it the input stream to, say, a file? So I'm going to go ahead and I'm going to type in input stream, because that scanner requires me to give it an input stream. All right, so I'm looking at a input stream here. And notice here we have direct known subclasses. That is, what other classes build on top of input stream. And one of them here is called a file input stream. So I'll go ahead and click on that guy. As I scroll down, I see that, oh, I could build a file input stream using the name of a file. All right, now this is going to get a little bit weird. We'll have to see how online GDB actually handles this. We're going to build it the way we think we want to build it. So this is a file input stream. It needs a string name. I named my file map.txt. And just real quick, file input stream lives inside of java.io. So I need to import java.io. I'm just going to be lazy there. Just give me everything from java.io. I'm going to create a file input stream fin is equal to a new file input stream, and the name of my file is map.txt. Just get rid of these lines for a second. All right, so I've given it the name of my file. Now, one issue we run into here with Java that we didn't run into, or that we wouldn't run into with C++, is by default. Now we didn't do file IO in C++ though, right? Yeah. So, but if we had, C++ by default will look in the local directory. Java becomes a little bit weird because since it's running inside of a virtual machine, it's technically, its runtime is not in the current directory. So we have to see how online GDB handles it. Will it let me just give it the name of the file from the current directory to read in? Or is it going to force me to give it the full path to where that file lives? Well, we'll have to see. All right, so now as we have it here, it's going to yell at me saying uncaught exception. At least I presume it's going to yell at me. Yeah, file not found exception. All right, so let's go and look at what does that mean. So if I click on this guy, file input stream, the one that takes a string name as a parameter, notice it has something after it called throws. This throws a file not found exception. So exceptions are the ways that a lot of our modern programming languages handle runtime errors. All right, so it's our ability to say, for instance, if we say I want to open a file and that file happens to not be there, that would be an error. Like, your file didn't open. Don't try to do stuff with this file because I didn't give you anything. You don't have an input stream. You gave me the wrong file name. This is your way of dealing with it. Okay. Now, what's a little bit inconvenient? Well, it doesn't have to be inconvenient. We'll cheat here in a second. I'll show you. But what they want us to do in this situation is do something called a try catch. we have something called exceptions. These are formal ways to handle runtime errors. And we're going to say must be handled if a function throws an exception. You have to handle it. Now, there actually is a certain kind of exception called a runtime exception that doesn't actually force you to handle it, but let's just pretend that doesn't exist right now. We're just going to say all exceptions make the responsibility of the programmer using that class. They make us deal with it. Okay, it's our problem, and Java's happy to scream at us here if there was an exception and we didn't deal with it. That's what's happening right there. So what they'd want us to do is they want us to try to do some stuff. I'm just going to put all the things that I want to try to do inside there. I'm going to try to do some stuff, and then I will catch this file not found exception. And then maybe I can do something like file was not found. So I'm going to try to do this stuff. And if something bad happens in there, rather than my program just crashing, I will catch the bad thing that occurred and deal with it in whatever way I deem appropriate. Now, because you can have as many lines as you want inside of this try block, potentially you might have a whole bunch of different kinds of exceptions that might occur in there. So you can handle those guys granularly. You can have a bunch of catches. You could say, I want to catch this kind of exception. So if this kind of exception occurs, do this. If some other kind of exception occurs, do this. Some other kind of exception occurs, do this. Now, good programming practice would say you should deal with each exception appropriately. If you're writing a professional level application where exceptions are a common thing and you need to handle them gracefully, you absolutely should do that. In our situation here, look, if the file's not there, a crash is just as good as handling it here. Okay, so we probably would not do a whole lot of error checking when we're doing kind of more of assignment type things. That doesn't say that error checking isn't a good thing, isn't an important thing. Now, I'm going to go ahead and show you file not found exception. So notice this guy throws something called a file not found exception. So I'm going to click on that. And notice that a file not found exception is actually an IO exception, which is actually just an exception. Exceptions are kind of like the object class to the exception types. So that means if I want to just have a catch-all, if it doesn't matter what bad stuff goes down in here, I could just say, look, anything that's an exception, catch it, deal. So maybe we just say, you know, bad stuff. So now if anything bad goes down in here, even though in our example right now, there's only one exception that gets thrown, but let's assume that we had 500 lines of code in here and there was 15 different kinds of exceptions that could happen in there. I can deal with all of those guys with this single catch. So I'm catching anything that is an exception. And since all exceptions come from, at some point in their lineage, the generic exception class, this will work. Okay. Now we could say here, so I'll go ahead and run this. Okay. It did find the file, so that's actually promising. So let me go ahead and I'm going to, instead of passing it system.in here, I'm going to say fin. That's my file input stream. That's what I named my variable there. So I'm going to build this same scanner now But instead of building it out of off the keyboard, I'm going to build it out of the file input stream associated with my file. And then I'm going to go ahead read something into my file. Same next line method that reads in a string. Same scanner variable input. I just happen to build it with a file input stream instead of system.in, which was another kind of input stream. Make sense? Now, if we're being really lazy here, we might say, look, some bad stuff can happen in there. And frankly, I mean, we would say that we kind of blew off the error, right? We just threw a bad stuff, whatever. Based on the way we're handling this error, we might as well not have done anything. So what we can do is we can say, I'm not going to do anything. Now I run this again, Java's going to scream at us again, though. It's going to say, hey, I just told you there's an exception and you got to deal with it. Okay, there's my exception again. So I'm going to say, no problem. I'll deal with it. I'll just pass the buck. So I can tell main, but this is where it gets a little bit problematic. I happen to be only in main here. And my exception occurs here, so I can tell the method that I'm currently in to go ahead and throw that exception. So I'm like, oh, hot potato, throw it out there, so you deal with it. Now it's no longer my problem. But the issue we could run into, and we'll see this run here. All right, so it's happy again, right? But the issue we run into here is, let's assume that we have a method inside of a method, inside of another class, inside of a method, whatever. If we're going to keep passing the buck, we have to keep tossing it up the hierarchy until it's finally main's problem. And main is where the Java virtual machine would actually deal with it. All right, so if we're going to be a lazy programmer and we're going to not deal with our exceptions locally, and instead we're just going to pass the buck, we got to remember that we have to keep tossing it up the chain. Probably that would be considered pretty bad programming practice. In our example right here, since we're sitting in main and we're not intending to do anything extra with our exception, deal with it in any sort of special way, we're probably okay saying, just go ahead and throw the exception. I only need to throw it once. But if we're deeper into our program somewhere and throwing, throwing it the exception makes another part of our program have to handle it, we might as well just deal with it locally. Throw it in a try catch, even if we're not going to make it a super, even if we deal with it lazily, we might as well handle it locally rather than pass the buck. But because we're already at the top level, all programs begin and end with main, passing it here is reasonable enough. Throwing it here is reasonable enough. All right, so now my file has multiple things in it. I want to read in the entire contents of this file, for example. I need to say, well, how do I know when there's something else to read? Well, let's go and look at scanner. See if there's something else handy in there that will tell us whether or not there is something else available to read. So we have something here called has next. That returns true if this scanner has another token that we might read. And this guy returns a Boolean, and it's non-static. So we need an instance of the scanner class in order to call it. So I can do something like while input dot has next. Go ahead and read it in and print it out. I'm just doing it all in one single ninja move. I'm printing something. What am I printing? I'm printing in the thing I read in, rather than putting it in a variable first. And I'm going to keep doing that over and over and over again as long as my scanner has something else to read it. So there's the contents of my file. But now we do want to see something here. If I look at my file has 4 elements in it, right? I'm going to create a counter. And every single time I read something in, I'm going to increment count. Okay, it read in 4 strings. That's actually a good thing, but it's something to know about file IO. We see that there are 4 strings here. Java is handling something for us that we would have had to deal with inside of some older languages like a C++. That is, at the end of a file, there is this hidden symbol EOF that says we are at the end of the file. That is actually a thing that would get read in under normal circumstances. Even though it looks like nothing, it still is a thing. So we would have actually read in 5 things here, and we would probably want to deal with whether or not there's a next thing. The way this historically would be would work is we would do something like this. Something like line is equal to input.read line. While that value is not equal to null, do something with it. Null is kind of our generic way of saying end of file. But Java is handling this for us. We don't have to deal with what end of file actually looks like, but that's something you might see in file IO examples for maybe some other languages like C, C++. Yeah, the answer is yes if you use the one of the primitive types for reading files in. So either fopen or open class. Those are pretty old functions. If you use something from one of the newer libraries, it very likely does the same thing Java does. Just like we used the string class last semester from using namespace standard. That has a lot of newer stuff in there that has some quality of life things. Correct. Right. But this was something worth investigating to make sure that the number of things we read in is equal to the number of things we thought we read in. Now, let me just do this. I'm going to go ahead and just press enter there. So that carriage return, that last carriage return with nothing on the last line, still got determined as that not being a thing. The empty string did not count as a thing. Has next, when it checked, because if I put 1 space in there, if I put a single here, let me single space in there, It's not reading into space. Do I have to save this file? That's interesting. So it's not treating, is that doesn't treat white space as a thing. If I put a single character in there, I better read it in 5 things now. Read in my 5 strings. That's actually fascinating that it won't let you have a line with the empty string using the scanner. Probably makes sense, but it's a thing. What if we skip the line? So we have an empty string and then we have Mike. Will it read in an empty string or will it read in the next value? Yeah, then it read in the empty string. And notice it did read in 6 total things. So only if that was the very last line. It handles that last line as a special case, it seems like. Where it says, look, if you either have nothing there, we're going to let you get away without an end of file. If you put a space there, you probably mean nothing. So it just says anything on that very last line is ignored, seemingly. Okay, so that reads some stuff in from a file. So now let's think about our rooms. So what I'm going to do is we're going to create a formatted file. We're going to write the file the way we want it to look. Modernly, if you were to look at, if we were to organize this data, we would probably write it in a format called Json. Let me actually just show that to you real quick. Well, I'll just kind of write it. We would probably have something like this, where a room has a name, and that name might be S118B. Let's see. Here's my map. And a room has a collection of exits and it has a current player. Okay, so by default, a room doesn't have much in it. So we would just have this guy set up as a room. And maybe at the top level, we have something called rooms is equal to an array of room objects. What do we call this guy? Hall 3 or something like that. So you might have a whole bunch of things in this format. This format is called JSON. That's JavaScript object notation. So we're going to say that this is a common format for transferring object info through text files. Now, having said that, there are JSON libraries for Java, but the one that's built in requires us to have a different version of Java than online GDB. So, and actually that's not even the preferred one anyway. So we'd have to bring in another library, kind of a popular one's called Simple JSON. Rather than do that in here, we're going to just pretend like we're inventing our own format for this, and we're going to write our own parser, but we're not going to write a parser for JSON. That it's not an impossible task. It just will take longer than what we're trying to accomplish here. So rather than use JSON for representing our data here, JSON might look like this, and it would go ahead and if we parse this with JSON, we would get a JSON object called rooms whose value is a JSON array that had a bunch of elements inside of it. each one of those is a JSON object that had a name value pair, name, and this value. So it will read it in for you already in a structured way. We're going to go ahead and just invent our own format. So we're going to have on one line, we'll say rooms. Somewhere later on, we're going to have exits. So where we say rooms, that's where our list of rooms starts. Okay. And let's start thinking about our rooms. So I'll just start here from, I don't know, we'll just go from top to bottom. So we'll say laser cutter. So that's the name of that room. Esports Lobby Network. S118D. S120, Hall 0. Hall 1, Hall 2, Hall 3. Lab 1 entrance. Soda room, lab 2. All right, so something along those lines. So we're going to fill in this. First, we're going to flag the, we're about to read in some rooms. Then we're going to have the names of all those rooms. Then we're going to have a way of representing our exits. All right, so we'll come back next time. We'll fill that out and we'll look at how do we read in those strings, which we've already done, and then parse them into their individual pieces so we can automatically build those objects. So the same thing you did for homework today, where you had a bunch of lines in there, we're going to write some code that will do that automatically just by reading stuff in from the file. Okay? Questions, comments, concerns, bribes? All right, I'll see everybody on Wednesday.